Hello viewers, I'm Folonsho Sule David, and in today's video with the White Academy, I'll be teaching you how to calculate the compression ratio of an internal combustion engine. Please do not forget to support this channel by hitting the subscribe button, and if you've done that, thank you very much. Kudos. Compression ratio of an internal combustion engine. In today's class, we'll be considering the definition, associated terms, derivation of compression ratio formula, and also we'll be looking into some solved examples. Now, coming to the definition, compression ratio is said to be the volume of the cylinder when the piston is at BDC, bottom dead center, to the volume of the clearance volume when the piston is at TDC, top dead center. Now, we need to understand this diagram before we proceed. This is the diagram of a four-stroke engine. We have the inlet valve, which is the intake valve, the spark plug, exhaust valve, the piston, and the crankshaft. Now, coming to the associated terms, the first on our list is called dead centers. We have two dead centers. The first is TDC and the second is BDC. Like I said earlier on, TDC simply means top dead center and BDC means bottom dead center. The highest movement of the piston is called TDC, while the lowest movement of the piston is referred to as BDC. Second on the list says stroke. The movement of the piston from TDC to BDC or vice versa is called stroke, and we have to look into the stroke length. Coming to the stroke length, it is the height of the piston or the height of the cylinder from TDC to BDC. So we refer to this region as the stroke length, and stroke length is represented with the letter L. Now, stroke length have a formula which says L is equal to 2R. Now, how did we get our 2R? We got our 2R from the diameter of the crankshaft. The diameter of the crankshaft, now we have 1R and the second R, because diameter simply means 2 radius. So the length of the diameter is equivalent to the length of the stroke. Swept volume, which is denoted by VS. The swept volume is the volume swept from BDC to TDC. As the piston moves from BDC towards TDC, the volume of the working fluid is referred to as the swept volume. And coming to general mathematics, volume is given as pi r squared h, where we have h as the height. So we want to convert this into a swept volume. So we'll be having swept volume equals to pi, instead of having r squared, because we are dealing with the diameter of the ball. So we have in bracket d over 2, because diameter equals to r. So we'll be having diameter divided by 2 to give us our r. The square is there. Now, instead of having our h, which is the height of the cylinder, we'll be having our stroke, which is the stroke length, which is L. Then this is the formula for the swept volume. And the next we'll be looking into is the clearance volume. Now, the distance from TDC towards BDC is also referred to as the swept volume in terms of volume, while from the bottom of the top dead center, which is the cylinder head, to TDC is called the VC, the clearance volume. So our formula remains the same for clearance volume. So we'll be having VC equals pi square L. That is this height this time around. So let's call this L2 and call this L1. So the formula remains the same for the swept volume and the clearance volume. So remember that our swept volume is given as Vs and our clearance volume is given as Vc. The next is cylinder volume. The cylinder volume is the sum of our Vc plus Vx, or Vx plus Vc. So that's our cylinder volume. The cylinder volume is the total volume when the piston moves from BDC to the head, the bottom of the cylinder head. That is our cylinder volume. So coming to compression ratio now. Compression ratio equals cylinder volume divided by our Vc, which is the clearance volume. So we have clearance volume. This gives us Vc plus Vs all over Vc. This is the formula for our compression ratio. Now let's look into some of the solved examples. Now we have a given example. It says determine the swept volume of a cylinder with a bore of 4.5 inches and a stroke of 4.8 inches. So let's go for our solution. Now remember that our swept volume, which is Vx, equals pi into bracket the diameter square times the stroke length. So let's bring out our parameters. We have our swept volume is unknown. Then our pi equals 3.142 or 22/7. So we are not using 22/7, but we are going for 3.142. Then the diameter given, which is the bore, says 4.5 inches. So we have 4.5. And our stroke length, which is the stroke, given is 4.8. So we have our L equals 4.8. So let's impute that into this. We have Vs equals 3.142 into bracket 4.5 divided by 2 all squared multiplied by 4.8. Now we want to apply board mass. So it says that we have to treat the one in the bracket first. So let's go by this. We have Vs equals 3.142 into 2.25 square times 4.8. So we are still working with the brackets. We have Vs equals 3.142 into, when you multiply square this, you should be having 5.06 times 4.8. So we are doing all the multiplication. Remove the bracket. We have Vx equals 3.142 multiplied by 5.06 multiplied by 4.8. And if we should multiply this, we have our Vs equals 76.312. Now, the square volume have a unit, and the unit has to be imputed. So currently what we're given is inches. So we'll be having Vx equals 76 centimeter inch. That's say inch. So on a norm, it's meant to be cubic centimeter or this. So, but since we have cubic inches, so we leave it as a cubic inches because the question didn't ask us to take it to either cubic centimeter. So we have to leave it as this. Now, looking into the second example, we have the board says find the displacement in cubic centimeter of a V8 engine with a bore of 97 millimeter and a stroke of 86 millimeter. So let's go to the solution, which says stroke volume equals pi into bracket diameter divided by 2 square times the stroke length. So we have data. Our stroke volume is unknown. Our pi is constant 3.142. Our diameter, which is the bore, we have 97 millimeter, and our stroke length, which is our L, we have 86 millimeter. Now, before we proceed, there is a particular conversion we need to observe because the question says we should provide our answer in cubic centimeter, but the data is given to us, we actually given to us in millimeter as the unit. So we have to convert from millimeter to centimeter. And doing that, we have 10 millimeter is equivalent to 1 centimeter. So in order to convert from millimeter to centimeter, whatever value is given to us must be divided by 10. And to this now, we have 9.7 centimeter and 8.6 centimeter. So we'll be working with this and not the millimeter. So proceeding, we have swept volume equals 3.142 into brackets 9.7 divided by 2 all squared times 8.6. So applying board maths, Vs equals 3.142. This should give us 4.85 square multiplied by 8.6. So we have Vx equals 3.142. So the square of this should be 23.5225 multiplied by 8.6. So we have Vx equals 3.142. The bracket simply means multiplication, so multiply by 23.5225 multiplied by 8.6. So our Vx equals 635.6. Now, thank you. Now, the question didn't ask us to look for swept volume, but it says find the displacement. So what we are looking for is displacement and not swept volume. So let's look for the displacement now. Let's take this up for space. So displacement, which is D, equals swept volume multiplied by number of cylinder. Swept volume multiplied by the number of cylinder, and the number of cylinder given to us is 8 because it says 8 V8 engine. So the number of cylinder is 8. So we have our displacement, which is equal to 635.6 multiplied by 8, and our displacement equals 5,084 centimeter cube. And lastly, example 3 says find the compression ratio of an engine whose swept volume is 635 cubic centimeter and clearance volume of 100 cubic centimeter. So we'll go for our solution now. So what we are looking for is compression ratio, and compression ratio says CR equals swept volume plus clearance volume all over clearance volume. So we have our data given. Our compression ratio is unknown. The swept volume, which is Vs, equals 635, and our clearance volume equals 100. So let's input that here. So we have CL equals 365 logs 100 divided by 100. So we are going for the addition first. So we have CR equals 735 divided by 100. And this will give us CR as 7.35 over 1. So let's approximate the first one. So CR now, CR equals 7:1. And this is the compression ratio of this engine. Thank you very much for watching, and please do not forget to subscribe. Thank you.